Hello everyone, engineering statistics and linear algebra. In the last video, Bi-variate expectations, uncorrelated, orthogonal, independent, correlated random variables x and y, and we have solved some problems on these concepts. Today we will solve some more problems on the concept. The problem is here, x is a random variable, mu of x is 4, it is a standard deviation of x, y is the one more random variable, mean of y is 6, standard deviation of y is 7, and correlation efficient of x and y is 0.7. If they have not mentioned the term x and y, obviously it is x and y only. And one more random variable u is defined in terms of x and y, u equals to 3x plus 2y. If this is the case, means calculate variance of u, covariance of ux, covariance of uy. Rewrite given data. Using this formula, let us calculate a covariance of xy. It is needed in further calculation, so that it should be the first calculation. Using this formula, that is a correlation efficient, a ratio of covariance of xy divided by a multiplication of standard deviations of x and y. Do the simplification, then covariance of xy is calculated and it is equals to minus 24.5. Let us recalculate a variance of u. This is the definition of variance of u. Here u can be any random variable here. It can be x, y, z, anything. It is a general definition of a variance. U minus mu u. Mu u is a mean of a random variable u. Rewrite the equation, and u is defined in terms of x and y. Substitute and apply expectation on both sides. We'll get expectation of u can be written as mu of u. 3 is a constant. Expectation of x can be written as a mu of x. 2 is a constant. Expectation of y can be written as a mu of y. Substitute all those values here. U is replaced by 3x plus 2y, and mu u is replaced by this equation. Then do the grouping here. From these two terms, take 3 as a common and x minus mu x. Then from these two terms, take 2 as a common, and this is in the form of a plus b whole square. A square plus b square plus 2ab. 3 square is 9, x minus mu x whole square plus b square. 2 square is 4 plus 2 into a into b. 2 into 2 into 3, it is 12 into a into b. Alright. Expectation operator is linear in nature, so that apply expectation operator inside the bracket. 9 is a constant, take it outside. First term. 4 is a constant, take it outside. 12 is a constant, take it outside. So apply the definition of a variance. It is nothing but a variance of x. You can compare these two. The term u is replaced by x here, so that this complete term can be replaced by a variance of x. 4 is a constant. This can be replaced by a variance of y. So this is the definition of a covariance of x and y, so that this complete term is replaced by covariance of x and y. And substitute the given data here. So a variance is given, but a standard deviation is given here. It is 5. 5 square is 25. Standard deviation 7 is given, but it is variance, so that square of 7 is 49. Covariance of xy we have calculated, that is minus 24.5. Do the simplification, we'll get the first requirement, that is a variance of u. that is 127. Alright, let us calculate a covariance of u and x. We know the definition of covariance of u and x, expectation of u minus mu u into x minus mu x. If the random variables are u and x, this is the definition, we know it already. Then rewrite the equation, substitute the value of u and mu u using this concept. U is already given 3x minus 2y, mu can be written as 3 mu x plus 2 mu y. So let us write this term as it is, and from this bracket do the grouping. Take 3 as a common, combine x minus mu x, plus from these two terms take 2 as a common, combine y and mu y multiplied with x minus mu x. Then multiply x minus mu x inside the bracket and apply expectation because of linearity property. X minus mu x into x minus mu x, it is square. 3 is a common taken outside, 2 is a common taken outside, y minus mu y into x minus mu x, that is written here. Alright, so we know it is nothing but a variance of x, it is nothing but a covariance of x and y. So standard deviation of x is given so that we can calculate a variance. 5 square is 25, covariance of xy is calculated, minus 24 and 5. Do the simplification, we will get covariance of u and x is at 26. Similarly, they have asked us to calculate a covariance of u and a variable, a random variable y. Rewrite the equation here, substitute the value of u in terms of x and y. Alright, mu u in terms of mu x and mu y. Do the grouping, take 3 as a common, write x minus mu x, take 2 as a common, write y minus mu y, then multiply this term inside the bracket and apply the expectations. 3 is a constant and 2 is a constant, y minus mu y whole square it is. We know this is a definition of variance of y and it is covariance of x and y. We have calculated a covariance of x and y, and a variance of y is given. It is given as a standard deviation, so that variance can be calculated squaring it. 3 into minus 24 and 2 into a standard deviation, it is 7 here. 7 square, it is 49. Do the simplification, we will get 24.5. Let us take these two problems as assignment problems. Same thing, the only change is a correlation coefficient is changed here. Follow the same procedure. In the first problem it is minus 0.2 and in the second problem it is plus 0.7. Follow the same procedures and solve these two problems. Alright, let us discuss a next concept, a bivariate transformation. Suppose we have a bivariate random variables x and y and know their respective means and variance as well as the covariance. Then we transfer x and y to u and v with the linear transformation. A u is defined here in terms of x and y, v is defined in terms of x and y. Mean, variance and covariance of x and y's are known here. The 3 points regarding x and y's are known here. The first one is mean, variance and covariance are known. If that is the case, means so that u and v's covariance, mean and variance can be calculated. This is the concept here. Let us take a mean of u, apply expectation on both sides. It becomes mu of u A is a constant mu of x, B is a constant mu of f, mu of y. This is the equation after applying expectation on both sides to this equation. Similarly, apply expectation on both sides, we'll get this equation. Alright. So the variance is calculated as follows. What is variance of u here? A variance of u is expectation of u minus mu u whole square. That is we know. Then can we replace u in terms of x and y and mu in terms of mu and mu x and mu y? Yes, that can be replaced here. U is replaced in terms of x and y. A mean of u is replaced in terms of mean of x and y. Then do the grouping here. From these two terms, a is taken constant, x minus mu x plus. B is a constant, y minus mu y whole square. Apply a minus b formula. Sorry, a plus b whole square formula. A square plus b square plus 2ab. Alright, that is done here. Next, apply expectation inside the bracket. A square is a constant, 2ab is a constant, b square is a constant here. It means a variance of x. It means covariance of x and y. It means a variance of y. We know all those definitions. So if this is known, a variance of, mean of and covariance of x and y's are known, then easily I can calculate a variance of u. Similarly, how to calculate a variance of u? Do the same procedure. Follow the same procedure. Replace u by v, mu by mu v. So do the simplification, we will get variance of u equals to c square into variance of x plus 2 into cd covariance of xy plus d square into mu. So these two formulas are very important here. The important formula is here covariance of u and v. Variance of u and v are calculated here, and this is the important and valuable formula. It is required for the further problems. You should keep this point in your mind. So simplification is not needed here. If you want to a simplification, means follow the same procedure. As a result, you will get this formula. So you should know the constants a, b, c and d. So where they are placed in the equation, it is a critical point here. So I suggest you to keep this formula in your mind. It is very much essential for the calculation of some problems in further slides. Keep this point in your mind, note it down. Based on this discussion, we do solve some of the problems here. So x and y's are correlated random variables with a correlation coefficient. It is 0.6. Mean of x is given 0.3. Variance of x is given 49. Mean of y is given 144. Variance of y is given 144. The random variables u and v are obtained using these two relations. Random variables u is defined in terms of x and y. Random variable v is defined in terms of x and y. What values can C have if u and v are uncorrelated? If u and v are uncorrelated, by the property of expectations, we can say that covariance of u and v is 0. I repeat, if u and v are uncorrelated, covariance of u and v is 0. That is already discussed. Keeping that point in your mind, using the given data, I can write a as 1, b as a c here. Don't get confused because of a general equation having a c, and in the given problem there is a constant c. Don't get confused here. So that I have written all the values here. In the place of a, it is 1. In the place of b, it is c. In the place of C, it is 1. In the place of D, it is minus C. Write all constant values very properly here. Don't get confused regarding this C. It is a value of C given in the formula. Sorry, given in the problem. And it is very important here. This formula is sufficient to solve this problem here. And they have mentioned U and V are uncorrelated, so that LHS should be equals to 0. Covariance of U and V is 0 if U and V are uncorrelated. And substitute the values of A is 1, C is 1, sigma variance of X is given, so substitute that. B into C, B is C and value of C is 1. Okay, it is C. A into D, A is 1, D is minus C, covariance of X and Y, minus B into D, B is C, D is minus C, it is minus C square into variance of Y. So this term becomes 0, C into C is 0, so all this term becomes 0. Do the simplification, substitute the values of a mean of X and mean of Y. Sorry, substitute the values of a variance of X and Y. It is already given. It is a variance of X is 49, a variance of Y is 144. Then do the simplification. C square is equals to 49 by 144. As a result, a value of C is equals to plus or minus 0.833. Alright, so solve these two problems. They are as simple as we have discussed. Only thing the replaced is a correlation coefficient. It is 0.7. Here it is 0.7 and only few of the data are changed. Follow the same procedure to solve these problems. This formula is the key point here. Substitute the values of A and B, and they have said that U and V are uncorrelated, so that LHS is 0. Substitute all the values, then only thing is C is remaining, then calculate that value. Alright, with these concepts we do wind up today's video, and in next video we will solve some more problems on bivariate transformations. Like, share, comment on the video, and don't forget to subscribe the channel. If you have any doubts, means feel free to ask me. Thank you.